This is problem number 9 from section 3.3. In this problem, they say the graph of a function is given below. Part A, use the graph to predict the number of real zeros and the number of imaginary zeros. Find these zeros using the quadratic formula. They give you the equation y equals x squared plus x plus 2. So for part A, we need to predict the number of real zeros and the number of complex zeros. Well, just so happens that it's pretty easy to figure this out. Anytime we're solving a quadratic, we set that quadratic equal to 0. Why do we do that? Because our solutions for our quadratic are the roots, which is where the quadratic crosses the x-axis. Now, those are the real solutions. So if you have a quadratic that droops below the x-axis and it touches it twice, you've got two solutions and they're real solutions. Quadratics always have two solutions, except for, in this one case, technically there are two solutions, but they're exact same solution. All right, so if you solve a quadratic like this, you would get two solutions, but they're exact same solution. So it's really just one solution. It's one real solution. So anytime a quadratic is touching the x-axis, you're getting real solutions. When it's not touching the x-axis, that's when you get the complex solutions. And anytime it's not touching the x-axis, you're going to have two complex solutions. Complex solutions actually go in pairs. So if you have one complex solution, you know there's a second one that's also complex. So in our graph, we notice it's not touching the x-axis. We have two complex solutions. So for part A, we're going to have two complex solutions. All right, so let's go ahead and solve this. So for part B, they say take the equation and find the zeros. Well, to find the zeros, we're going to take y and replace it with 0 and say x squared plus x plus 2. Now they want us to use the quadratic equation. That's fine. If we use the quadratic equation, we're going to have b be 1, right? So we're going to have negative 1 plus and minus, let's write x equals, root 1 squared minus 4 times a, which is 1, times c, which is 2. And we're going to put that all over 2 times a, which is 1. So we have x equals negative 1 plus and minus. This one's easy enough that I can just say that this is going to be root 1 squared is 1, minus 4 times 1 times 2, that's minus 8. So we have 1 minus 8, which is negative 7. And that's over 2. So that's going to equal negative 1 plus and minus root 7 all over 2. And oh, I forgot the I. So the reason I wrote root 7 is because I'm taking that root of negative 1 and I'm changing it to I, because I is root negative 1. That's our imaginary part there. X equals, we'd have negative 1 plus and minus I root 7. We're going to split the denominator of the 2 to the 1 and there. And finally, we're going to write that into two solutions. So x equals negative 1/2 plus I root 7 over 2, or x equals negative 1/2 minus I root 7 over 2. And these are the solutions to this problem. And as you can see, we end up with two complex solutions, which we predicted above.